Okay, so our speaker is Lance Lakey, and without further ado, I'll give you Lance. No.
Am I on? Yeah? Okay. Thank you. I'm actually not Lance. We were going to give a talk together, and but Lance is out sick. First of all, good morning to everybody. Thank you for coming to my talk, and thank you for SCaLE, or to SCaLE, for organizing this great conference. And it's become a fixture in the LA tech scene, and it's always a great opportunity to catch up with folks. And I see a bunch of people that that I know from around the LA tech scene, and it's good to see you. The talk, we have a stealth title for the talk, as you may have picked up, introducing Huxley. So Huxley is the framework that we built around the model for using Docker and CoreOS and Git. And so I'm going to talk as much about the journey that got us there as I am about the framework itself. It's probably more interesting what the model is that we're pursuing as it is, exactly, what Huxley is. But we're also very excited about being able to possibly introduce it's an open source framework for implementing the model that I'm going to talk about. Like I said, my name is Dan. Lance was going to be here, but unfortunately he's out sick. And Lance, a few years ago, I gave a talk where at various intervals throughout the talk, including right about at this point, at the beginning of the talk and then all the way through it, I could hear peals of laughter from the next auditorium, which is really intimidating, when you're trying to give a talk, and my talk was, I'm a very serious person, and so I was giving this very serious talk, and I was trying to make really impressive technical points, because, you're a technical conference. It seemed to make sense at the time. So I vowed, never again to give a talk without an accomplished improv comedian on the stage with me, which Lance is an accomplished improv comedian. Unfortunately, so he's out sick. He's also an accomplished DevOps engineer, which is helpful. But unfortunately, since he's out sick, this isn't going to be a very funny talk. Well, maybe. So we work for a company called Panda Strike, and we're a DevOps shop and a dev shop, which seems like there should be an efficient way to say that, but there isn't. So if you have custom development needs or you want contract DevOps help, come talk to me, but that's not what the talk is about. Our journey is going to start with Docker, which is really about Linux containers. So since you can Google Linux containers, and probably most of you are, show of hands, is everybody pretty familiar with Linux containers? Okay, good. So most of you are, and it's basically kind of the short version is it's a somewhat more efficient, sort of the evolution of the virtual machine, if you will. So, but I'm not going to spend a lot of time talking about what these technologies are. Instead, I'm just going to talk about how we're using them. Now, the reason that I think Linux container technology is important is that I believe that in 5 to 7 years, pretty much everything we deploy, the sort of de facto way that you're going to deploy new applications is going to be inside of a container. How many people would agree with that assertion? Okay, so we're about 30% maybe. Somebody said 3 years. All right, yeah. A lot of you are skeptics, and I think with good reason. There's always good reason to be skeptical. I'm not here to sell you a silver bullet or a cure-all, magic cure-all solution, right? In fact, a lot of our journey has, and a lot of the story I'm going to tell you has been us, getting in trouble with this technology. So, however, I remember, because I'm old and I have a story for everything now, I can remember sitting in a meetup where we were having somehow instead of somebody just talking at everybody, we'd somehow ended up having a conversation. And the conversation was that this new cloud computing stuff that Amazon was pushing on everybody, was crap. And it was a recipe for disaster, and if you deployed your apps, on the Amazon cloud, you were just, asking for trouble. And I think we all know how that turned out. If you don't know who that is, that's Jeff Bezos laughing about how rich he is. And it's not that there weren't problems. There were a lot of problems. And there's going to be a lot of problems with Linux container technology. In fact, there still are problems. This is recent. This is last year. But the thing is we, for whatever reason, and I'll talk about what the reason is, we keep trying to figure this stuff out. We keep saying, okay, fine, you want to throw some new technology with all kinds of risk at me, I'll figure it out. We'll do our job. And the thing is it's a little bit of a mystery in a way, like, why do we keep doing this to ourselves? We get something figured out, we get it kind of working, and then we decide, no, let's do it a whole different way. And that's what Linux container technology is. And it's really mystifying because nobody wants the system to go down. It's not like we're actively conspiring to screw ourselves here. That's not the right answer. It's not job security. Well, maybe for some people, but that's not where I was going with this. And what's a little bit frightening about that is that guy works for me. The reason is that the customers, the people we're serving, keep raising the bars. We get something figured out, and then they go, okay, well, I guess you got that now, huh? Like, I've had, every time a conversation with a client starts with the phrase, like, how hard would it be? Like, I know I'm in trouble, right? I know, like, oh, this is going to be a bad conversation. Because we're not deploying this anymore. We were at one time, a long time ago. We were just, CGI script, and wow, I got a website running. And then, oh, I got a database. Woo! And then we're not doing this anymore either. In fact, this is sort of like the starting point now. If you're serious about, getting something that's going to be reliable, and our starting point more often than not nowadays is this. We're already thinking like, okay, if this thing starts generating some traffic, let's just be prepared so that we're not, so we just don't have to sweat it later. We don't want to have a fire drill down the road trying to figure out how to get something to scale. Some of our clients even want this pretty quickly. Like, we even tell them, like, you don't really want to do this. It's kind of expensive, but no, we do. That's what we want. We don't want the system to go down. It's mission critical and all that kind of stuff. We had a launch recently with a client where it was a successful launch. We were really excited about it, right? We were like, yeah, we did a good job, right? And hoping the client was just going to sit there and tell us how awesome we were. Instead, they were like, well, everything's great except we're really popular in Japan, which we didn't have a data center set up in Tokyo, so now we know what we're doing for the next couple of weeks. And more, that's the kind of stuff that's happening. The web is increasingly a global phenomenon. Mobile apps can be used anywhere. You can't entirely know where you're going to get traction. Like in this case, they didn't actually know they were going to be big in Japan. So, we're looking at this, and we got the clients are raising the bar, and we're still trying to do stuff the same way we were doing it before, and it's not really cost effective. So that's why we keep doing this to ourselves. That's why we keep figuring, okay, let's try it this way. So with us, you know, we started looking at Docker, and we started thinking, all right, well, how could we do things differently with Docker? And that led us down this rabbit hole that I'm about to describe to you. We asked ourselves the question of, what if our DevOps practice just thought in terms of containers? You know, what if we were just managing a cluster of machines that just runs containers, and to us, everything just looks like containers, and we don't care what's in them. We don't have to think about, like, we don't want to know what's going on in those containers. You know, that's your business. And the app developers could sort of build their things. As long as they could all run in containers, we would just be automating the process of deploying these containers to these clusters of machines designed to run them. In the world, instead of looking like the picture on the right, which is how it looks now, it would look like the picture on the left with a bunch of stuff just spread out across containers. There's a little bit of nuance in how you spread that stuff out, as it turns out, but I'll get to that in a second. So we started looking around for, like, okay, you know, has anybody done this? Has anybody run, you know, stuff in containers on a cluster of machines? And it turned out there was a whole company whose entire business model was doing this. Well, now it's turned out it wasn't their entire business model. They're slowly revealing that their business model is to compete with Docker, and Docker's trying to turn into CoreOS, and I don't know where that's going. But at any rate, that was an exciting find at the time. Like, here's a distro whose entire purpose is running Docker containers. And now I guess its entire purpose is running Rocket containers. I don't know how many of you people have been following this stuff, but so we thought, all right, well, that was easy. That wasn't tricky at all. We tried it out. We ran a Docker container on a CoreOS cluster, and okay, that was surprisingly easy. We're off to a great start. And just as some background, we had been playing around with Docker by itself already. This was us starting to look at it more seriously in terms of, like, could we actually use this with clients? So the next question we said is, all right, well, we got to have a way to run, we got a cluster that's basically a giant pool of resources, right? So we need a way to run stuff on the cluster. We need a way to sort of just blindly say, hey, we've got an app, you know, can you run this? And have somebody looking at the cluster going, well, no, I can't. I don't have enough capacity to run that, or alternatively, I have a ton of capacity, and sure, it's no problem. Thanks. All right. So we looked at Apache Mesos, and I briefly got excited about Apache Mesos until I actually tried to install it. How many people are using Apache Mesos? Okay, I think maybe like there's two people. You know, three. Okay, three people. My hat's off to you. I got a little ways into that and was like, oh, okay. So then we thought, all right, look, all we need is something. We're doing something very simple, right? We don't need a general purpose resource allocation framework, which is what Mesos actually is. All we need is something purpose-built to do this one thing. All it's got to do is figure out how to deploy Docker containers. And so we started looking around, and of course, CoreOS had already thought of this, and they had a thing called Fleet Control, which was exactly this. It was purpose-built for starting up, well, really any kind of service on a CoreOS cluster. But, you know, the main use case, it's kind of a system D, and I know some of you guys hate system D. We're not, you know, like big fans or anything, but it works. It basically has an init file, and you can put pretty much anything in there, including Docker build and run commands. So, okay, that was nice and simple. We tried it out, and it worked. All right, you know, this is going really well so far, you know. Now we've got a way to just kind of request things to be deployed to our cluster. And so now we got a problem, though, of everything running on the cluster, and they don't know where anybody else is, because you don't know where they go. You don't know when the broker decides to put something on your cluster. You're not exactly sure what the endpoint is. And service discovery in general is an interesting problem. We thought, hey, you know, we thought actually at the time, we thought we had this brilliant idea that nobody had ever thought of, which is hilarious because there's actually an SRV record specifically for service discovery and DNS. But at the time, we thought we were the first people who had thought of, hey, what if we just use the domain name system already, you know, the domain name server framework that already exists for mapping logical names to physical addresses. That's what we're trying to do here. There's already a thing that does it really well and scales really well, and of course, we discovered that CoreOS was working on that. Now, this was good news because sometimes when you go look for something that you thought was a brilliant idea and no one's doing it, it could mean that you're crazy. That's a possibility, right? So we weren't crazy, but the bad news was that we had caught up to where the CoreOS guys were because they weren't done with this. It wasn't properly integrated yet into the CoreOS stack. And we tried using it, and it was you know, we were getting there, but this was where it started to get a little bit, you know, it was a little rough sledding there at that point. And fortunately, like literally the following week, reInvent came up and they announced Route 53's private DNS. So we switched over to that because we were already using Route 53 for other stuff, and it worked great, and all of a sudden we were back in business. So, you know, at that point we sort of stopped and went, wait a minute, I think we did it, right? We can define a service, we can request deployment of the service, we can actually have it get deployed, which is obviously the whole point. Sometimes you look at like the slides and the bullet, like in the middle of the talk, and you go, why is that in there? That's redundant. And we can register the endpoints of the service so that they can all now find each other. And we're like, okay, you know what? All the pieces are there. Let's start doing this. So we did. We started trying it out on internal projects and stuff. We were going to, like, let's get the hang of this, and then we can go to our clients and go, hey, you should run everything on Docker. We got it all figured out. And you know, the thing was, we started doing that, and we got to this point, which, you know, is pretty typical, right, of when you're doing new technology adoption. You almost always get to that point where you're like, are we sure this is a good idea? Maybe we should just go back to Ansible. But the thing was, you know, we had already solved this problem. We'd already done a lot of automation around the solutions that we had used in the past, Chef and Ansible in particular. So we weren't really comparing apples to apples. We were comparing stuff that we'd automated to stuff that we really hadn't automated because we hadn't done it, so we didn't know what to automate exactly. So like all lazy programmers, we figured out, okay, let's automate it. And this is where we start to move into stuff that maybe we can actually hopefully share with you guys. We created 3 open source projects and imaginatively named them, as you can see. And these were basically intended to automate the things that were making our lives difficult when we were trying to actually use this model of deploying stuff with Fleet to a cluster, a CoreOS cluster, specifically deploying Docker containers. Now these exist. These are actual projects. They're MIT licensed. We would love it if people kicked the tires, tried them out, told us what was wrong with them, you know, sent us pull requests, whatever. Huh? Yeah, again, so he's been saddled with doing a lot of the development, so he's like, please, someone help me. Just to tell you what these are, what they do. So Panda Cluster, its job is very simple. It's to stop CoreOS clusters in there's a CLI, and it can also be done programmatically through an API. And that's really its job. We can start and stop clusters. We can check on how they're doing, whether they're available yet. Not ways to a cluster that you actually set up, you know, that you clone your repo to each one of the clusters that you want to push to. You have to, you know, if you're running, if the developer wants to set up a test cluster to just kind of check out their deployment scripts, they have to run Panda Cluster to do that. And so we thought, you know, maybe we can actually make this even easier. And that's where Huxley comes in. Huxley is, as you guys hopefully all know is Aldous Huxley was a famous science fiction author who wrote a famous novel called Brave New World, and I believe that we're in a brave new world, hopefully not as dystopian as, or Linux containers represent a brave new world that's hopefully not as dystopian as the one in the book. Anyway, it seemed like a good enough reason. That's not even really the reason why we called it Huxley. We have a list of science fiction authors that we use as code names, and that was the next one on the list. But it sounds better if we talk about it as a brave new world. So again, we have these three pieces, and that was good as far as it went. And we thought, all right, well, what if we put those behind an HTTP API, install those on a box, put an API in front of it that knows how programmatically to talk to those pieces, and then we add a CLI in front of that. So now that knows how to talk to the API and possibly does some bookkeeping, so that you don't have to pass as many command line arguments. You know, maybe keep some local configuration information, that sort of thing. And so we thought, all right, you know, that seems like a promising idea. Instead of installing, you know, multiple little pieces and having to figure out how each one of these work, we would just have one uniform interface for this whole arrangement. And so that would allow us to do things like this. We'd have this nice single command line, and we would be able to, you know, spin up a cluster. You know, the developer could spin up like a little local cluster for themselves, you know, from everybody just be using the same interface. And then, you know, we could extend it to support, okay, I want to initialize, I'm working on a repository, I know I'm going to use Huxley with this, I want to initialize it, so that allows us to save a bunch of information that we can then use to talk to the API later. I want to add a remote, so this is the whole get hook thing. I want to be able to, you know, add a remote that I can now push to deploy. So after that command runs, I want to be able to get push staging. And then we add this idea of adding in mixins, and this goes back to this interface again between the developers and the DevOps people. And mixins, there's the origin of the use of the term mixins goes back to an ice cream shop in Boston, at least my understanding of it. And there was a bunch of MIT developers who were building a new dialect of Lisp called Flavors Lisp. And Flavors Lisp, the way that you would add features to your application, like if you wanted to add a menu bar or a scroll bar, you'd use what were called mixins. And so we thought that's a perfect idea here. We want to be able to mix in pre-built launch configurations into your app. So now, instead of the developer being on their own in that, and God knows what they put in those files, we're in a position where maybe we can provide a whole bunch of these sort of out of the box. And so the idea would be, okay, here I've got my web app, and I decide I want to add a database to the web app. So I say, okay, add the HA Redis mixin. And now my launch directory, after possibly you know, looking at my project information and filling this out, these would be generated files from templates. I now have added another component to my launch configuration. And when I do a git push the next time to one of the clusters, it's going to deploy the HA Redis. Now, what this allows us to do is this gives us an interface now between the DevOps team and the engineering, the application development team, right? Because we can have these mix-ins. The developers, if they don't like something, they can issue pull requests saying, you know, I tested this out on my local thing, and it would be cool if it did this too. And then the DevOps team can either, okay, yeah, that sounds cool, or boy, that's crazy. There's a reason we didn't do it that way. And now there's, you know, there's a sort of a mechanism for a dialogue to take place about how we're going to launch these things and what does it mean when you have an HA Redis component. And again, just to try to make this a little more concrete, the way this ends up looking, right, is I have some kind of, this would be like my application configuration file. And each one of these components announces itself, right? So they have endpoints that we can reference in configuration files. So when my web server starts up, you know, it can find Redis by looking up these endpoints. And we know those are the endpoints because that's how the mixin was templated. It's, you know, that's the way, that's the default name that it wants to use is Redis and then a number for however many instances. And so, and we can also have a a public endpoint that we publish as well, which would be like the name of the app, and maybe, again, Huxley and Knit has given us some, allows us to configure that information about what endpoint do we want to publish for the app itself. And so, if I push the staging, that might actually say my app, .staging.acme.com or whatever. So now, I'm going to take a quick step back, and then I'm going to talk about sort of the status of all these projects. Linux containers, the whole premise of this idea is that these are very disruptive technology, and we need to figure out how to use them, and we need simple and effective models and development process for using them. And we basically have a cluster that's pre-configured to support push-based deploys through Git and service discovery through DNS. We wrap the core functions of that in an API that we can access via a uniform CLI interface, and that's Huxley. We move to self-describing deployments, where all the information that we need to deploy an application is in the repository itself. We use mix-ins to communicate and sort of abstract away what a component is, what the precise definition of a component is. The DevOps role shifts a little bit more towards managing clusters and container deployment. Everything looks like containers, as well as managing a library of these mix-ins, so that they have some idea of what's being deployed without necessarily having to block or own that piece of the puzzle anymore. So, in terms of status, I've talked about a whole bunch of stuff. Originally, what I was hoping at this point, and now David's going to hang his head in shame, I was hoping at this point that I was going to be able to say, and all of this is working beautifully, and it's perfect, and you can download it here and sign up here, and unfortunately, it's not all done. We sort of got about 60% of the way there. These three pieces are the farthest along. They're basically in an alpha state, meaning, they're code complete. We finished the development on them. We're still working on some edge cases, bug fixes, documentation, and so forth. Huxley itself is under development right now. Right now at this point, it's something that you can use. It sort of works, but it's still changing quite a bit, and hopefully over the next month or so, we'll be able to finish that up as a legit open source project. And we're also looking at the possibility of introducing it as a service, subscription-based service, where we would run a Huxley server for you. I'm very interested in if people would be interested in that. We haven't really decided for sure what we're doing with that. These, again, are all open source projects. You can find them on our GitHub account, pandastrike / github.com, pandastrike / and then whichever one of these things you're interested in. And then if you're interested in the Huxley as a service, I would appreciate it if you went to our website, pandastrike.com/Huxley, and then joined the beta. There's some information about Huxley, most of the stuff that I've just shown you here. If you are interested in that'll probably be one of the things that we use to figure out whether or not we want to try to offer it as a subscription-based service. So if that's of interest, please sign up there so that we know, we get a sense of that interest. So that's the talk. That's what we've done. That's the model that we're pursuing. I would love to hear from any of you in terms of what you're doing, or whether or not this model is appealing. I think it's still very early, and there's lots of different approaches. My name is Dan, and I'm available at dan@pandastrike.com. That's the easiest way to get a hold of me, or of course talk to me after the talk. Or you can ask questions right now. We have a little bit of time for people to ask questions if anybody has questions. Yes?
How do you deal with containers that require persistent storage? So, for example, a database container that let's say I want to containerize so I can replicate it in dev and in prod. When I deploy it on the fleet of clusters, a cluster, then I don't know what machine it's going to land on.
Yes, we attach, actually, that's a great question. I'm not sure what I know we have an answer to that in terms of attaching persistent storage to,
every container that gets launched will have an opportunity to announce specific endpoints in the DNS so that you can identify.
no, but if we want to be able to make sure that we can keep track of the storage, right?
Well, there's three options, right? So you've got NFS or NAS mounted storage persistent in a container. You've got SCaLE, you can do block level storage, or you can have a file system container just persist the data into another container that's exclusively file system.
But how do you know where the file system container is going to be?
It has to be linked to your database container.
Right, but if you just deploy it on a cluster, you don't know what machine it's going to land on, right? Unless you bootstrap your cluster from.
Oh, I see what you're saying. Yeah, so that's why you have block storage behind the cluster, like a set or something like that, and you persist into that, independent of your containers.
I mean, is that performance-wise comparable to having local storage?
Yes.
Yeah, I believe that's what we're doing. We're attaching block storage to the, I think to the Docker container, right? Or,
Things you can do like snapshots and backups. Lots of stuff you can do that too.
But can I replicate that in that environment? Okay.
other questions? Yes?
Are logs handled automatically? Like for like a web service log, you have 3 web service containers, and the logs like this somewhere.
You need logs for that.
You could probably do that automatically. I don't believe we do that. We don't have automatic logging. You'd have to set that up for each application.
There's a cool tool to do that called Logly. There's a lot of work being put into Logly now to lace logs together and aggregate them up so you don't have to run like syslog in each container, hacks like that.
Yeah, I mean, typically that's what we've been using is Logly, or more recently we've been setting up elk stacks. But yeah, I mean, we actually do that as like, in fact, one of our example apps that we've been playing with is an elk stack. Like, so can we have an app with the launch config that just describes an elk stack so we can spin up elk stacks very easily? Any other questions? Yes. So the question was, what makes the cluster a cluster? Basically, yeah, it's basically a bunch of EC2 instances on a VPC in Amazon using a CloudFormation template from CoreOS. That's how we're doing it right now. What?
Well, one powerful thing is that because we have control of the DNS, we can define our own network topology. So it's a network of containers, and not just, you don't have to think about the instances that are running, but you have the actual containers, you have cloud containers, so you can do whatever the hell you want with. And that
Trying to figure out how to boil that down. I mean, isn't that just because it's a VPC? Yeah. So the key thing there, the thing that ties it together is that they're on a single VPC. Yes?
Are you guys using IPv4 or IPv6? You guys doing
I think we're just using IPv4 right now.
LANs or
Are we using IPv6 or IPv4?
just standard v4?
Yeah.
No bits in the way, no VXLAN, nothing like that? You're not stretching across physical sites or data centers?
No, not at this point. No, nothing like that. Nothing.
established more to go across or an assessment to basically something.
Right. Yeah. No, we haven't gotten to that yet. That definitely would be, yeah, would be nice
That's
for.
where the demand will go there to extend the cluster to other physical sites to provide resiliency and DR.
Right.
That'll be the next step.
Yep.
And then IPv6, you can abstract away from physical locales.
Yeah. Right now, the thing that's exciting is just being able to spin up the 2 data centers reasonably quickly this way, but then getting any kind of communication between them is right now we'd be back to where, to how we do that today.
Yeah.
Yes.
Is this purely a EC2 solution, or you're also targeting OpenStack, open cloud?
Right now, it's purely Amazon. It's but there's nothing architecturally, I don't believe, most of that is pretty well abstracted at this point. Like it's behind, like within Panda cluster, and there's it's a programmatic API, and it's not particularly Amazon specific. There'll probably be a couple of things, like always, if you try porting to a different platform, you're like, oh, well, now we need to provide this extra parameter or something. But it's not, from an architectural standpoint, I don't think there's anything that would be preventing people from extending and adding, like, okay, I want to add an OpenStack implementation of this. The interfaces are pretty generic. It's like start a cluster. Well, okay, as long as we have a way to say, programmatically start a cluster, and those interfaces, like in Panda cluster, those are all just methods. So if we were to make that implementation swappable, right, and then you have an OpenStack version of the same thing, it should work, right, as long as obviously you don't mix implementations. But yeah, I don't see any reason. I think it would be cool to actually ultimately get to the point where you could deploy in whatever infrastructure you wanted. We've still got a couple more minutes if there's any more questions. Yes? What if, I'm sorry, I didn't quite hear you.
How do you handle resilience? When the services that you have starting to be as kind of
Oh, right. Like, so your entire deployment depends on this. Yeah, at the moment we don't, but what we would do, where we would go with this is like you would with any web app, right? We would actually have multiple, the HTTP interfaces would be served by multiple servers, and the backing data store would have a master-slave type of configuration, or a Redis cluster or something. Right now we're using Redis, so maybe we might even use a Redis cluster there, so that we'd have everything, so that we'd have an HA deployment of Huxley itself. Yeah, because obviously you don't want to suddenly just, we can't deploy, everybody's stuck. Yes?
How did the Git hook work in this scenario? I felt like that wasn't totally clear.
Yeah, it's actually, the way it works is you clone the repo to the cluster to where the Git hook server is running. And then we have sort of a generic hook script, right, that we then copy into that repository as part of that process. That's part of what Panda Hook is doing. Now that hook script is what knows to go through the launch directory and look at each one of those subdirectories and run in turn the Docker file, well, really it runs the service file, which in turn references the Docker file, but it knows to go through each one of those directories on a push and run each one of those service files.
So this is on a push. What is it that actually, which component is it that actually does the executing of this? Is it the Panda Hook?
So Panda Hook just sets up the hook script for the repository. The script is actually calling fleet control start with that service file. And fleet actually is the CoreOS component that looks at the cluster and decides whether or not it can deploy that particular component. Does that make sense? I'm not sure if I answered the question. Basically, Panda Hook is the thing that configures the hook server for a specific repository. So you would run the Panda Hook script, or you'd run Panda Hook, and it would communicate, and point it at, okay, I want to configure this cluster to be able to handle with a receive hook, and that, it'll make a bare clone of the repo, set up the hook script on the cluster that and then you have to add a remote, and this is the part that Huxley does for you when you do Huxley remote add. So you get that cluster set up, and then you add a git remote that points at the cluster at that endpoint. And so now when I do a push using that remote, that'll trigger that hook script, which then runs fleet control. Yeah, so Panda Hook doesn't actually do the push part of it. Is you do get push, and the hook, the get hook, does the rest. Any other questions? We got 3 minutes left. No? Well, thank you again, and enjoy the rest of the conference. Thank you.